So now let us understand what is TCCR and what is OCR. So these two are nothing but the hardware registers which are used to set the mode of the timer and the compare value for the timer, right? So each timer has its own TCCR registers which is split into two parts, A and B. So for timer 0, timer 1 and timer 2, I have split the TCCR register into two parts, A and B. You can see here, right? Now let us understand this with the help of an example, right? So in this line, we are setting the CTC mode for the timer 1, right? This line is used to set the mode of the timer. Now there are many types of mode like normal mode, CTC mode, fast PWM mode, and there are many more, right? So I'm not going to discuss all of them, otherwise the video would get too long. If we talk about the normal mode, then in normal mode the timer overflows after reaching its maximum value, right? Like in this example, the 8-bit timer, the maximum value of overflowing is 255. That means after reaching this value, the timer overflows and starts from again 0, 1, 2, 3 like that. So this is the normal mode. And in the CTC mode, what happens? The timer overflows after reaching the value which is set in this register OCR, right? So we have set the value 19,999 in the OCR register of uh, this timer 1, right? So after reaching this value, the timer overflows. So this is the CTC mode. Basically, CTC stands for clear time on compare, right? Let me write here, clear time on compare. So basically, OCR register this value. This value is called the compare value, right? So the timer will be cleared on comparing this value. As soon as the value of the number of ticks of the timer reaches this value, that means the match happens at this value, the timer will be cleared. That means start from 0 again. So this is about the OCR register. Now let us understand that what are the bits present in this register. So for at Mega 328P, which is this microcontroller Arduino Uno, right? The TCCR 1B bits are defined like this. So these are the bit name and these are the indexes 76543210, right? So because this Atmega 328P is a 8-bit microcontroller, so that's why we are having here 8 bits, right? So on the 0th index, the bit name is CS10. On index number 1, the bit name is CS11, and you can see here all the bits are named corresponding to their index, right? And please note that there is no bit name corresponding to index 5. If you check the datasheet for Atmega 328P, you will not find any bit name for this index, right? So in this line we are setting the CTC mode, and in this line what we are doing, we are defining the prescaler value. So now let us understand these two lines in detail, right? So let me show you the example or the explanation for this. So in the first line we are defining the mode of the timer, right? And this symbol is basically representing the bitwise OR operation in this line, right? So this operation sets the selected bit from 0 to 1. If it is already 1, then it will not change, but if it's 0, then it will change to 1. And this symbol, that means OR operation, does not change the other bits. Suppose in this example we are choosing this bit, that means selected bit here is WGM12. So WGM12 will be replaced by the corresponding index. So the index corresponding to WGM12 is 3, right? So the operation will perform like this. 1 left shift, replace WGM by 3, and the result will be 0000100, right? And let's say the initial value of TCCR1B is this 0000, right? All bits are 0. Then the final operation will look like this. TCCR1B TCCR1B bitwise or with this value, right? This value 0000100, right? So the final result will be this one 0000100, right? So observe that the selected bit, that means WGM12 has now been changed to 1, right? This is for CS10, this is for CS11, this is for CS12, and this is for WGM12, right? So initial value of WGM12 in this bit is 0, right? This is 0. But after performing this operation, the bit has been changed to 1, right? So compare these two values. The bit value of the WGM12 register has been changed to 1, from 0 to 1. So that is a function of this OR operation. It changed the selected bit from 0 to 1, right? Now let us discuss that what is the meaning of the second line, in which we are defining the prescaler value as 8. So before discussing that, I want to show you this table, in which I have given different combination of the last 3 bits and the corresponding the prescaler value. Okay. So these last 3 bits are the deciding bits that what should be the value of the prescaler of the timer. Suppose the combination is 0, 1, 1, then the prescaler value is 64. And if all the bits are 0, then the timer is in stop condition. That means the timer has not been started yet. Okay, and if the combination 0, 0, 1, then the prescaler value here is 1. No prescaler means prescaler as 1. So now let us move on to the explanation of the second line. So CS11 will be replaced by the index number. So from this table, the CS11 index is 1. So it is replaced by 1. So the result of this operation is this, right? And for the sake of simplicity or for the sake of explanation, I am taking the initial value of TCCR as this 001, right? And if you perform the bitwise operation of these two, this much and this one, so you need to perform like this. So let me know in the comment that what will you get after performing this operation, and compare that final value with this value. Okay, and you will notice that the bit of the CS11 has now been changed from 0 to 1. Okay, in your final answer that you will get after this operation. So the final combination that you will get in your answer will be like this: 0, 1, 0, right? So this last bit is for CS10, this is for CS11, and this is for CS12. So match this combination from the table, and you will observe that the prescaler value is coming out to be 8. So 0, 1, 0, the value is 8 for the prescaler, right? That is why the prescaler value is here is 8, because of this combination, okay, that you will get after performing this operation. So drop down your answer in the comment section. Now let us discuss what is counter. So a counter is basically a hardware register like a timer, but instead of counting the internal clock pulses which is generated by the crystal oscillator, it counts the number of external events or the signals on a specific microcontroller pin. So counters are associated with a single microcontroller pin. Okay. So these are some of the use cases of the counters, like for counting the number of rotations of a motor shaft, which is an external event, or the counting pulses from a sensor, or measuring frequency of an input signal, right? So the basic difference between a timer and counters is that in case of timer, the clock source is the internal, that means the crystal oscillator. But in case of counter, the clock source is external pin, okay, or the input pins. And the timer increments on each clock ticks. As the timer keeps on counting the number of ticks of a cycle or the clock cycle, it keeps on incrementing. But counters also increment, but they increment on each external event, right? So counter are related with the external events and timers are related with the internal events, right? So I hope you have understood whatever I tried to explain you. We will meet in another video. Till then, goodbye.